So, hello everyone, welcome back again. And today we are doing the second part of week 3. It will be a short part and not a long one, and I can guarantee that thing to you. And in today's part, we are going to study mainly two topics, short ones, and not important from your exam point of view, but definitely important in cases like regression, in your LLMs, and all of these things, in machine learning, and all of these. They are correlation and covariance. So as I told you that I will be giving you the second part as well. So this is the second part. So let's see what is correlation and what is covariance. All right, not covariance, sorry, correlation and inequalities. Yeah. Okay. So what is correlation? What does the name suggest? Just remove this co part. Okay, remove this co part. What does the name suggest to you in actual? Correlation is nothing but it suggests you something like relation. And what is the meaning of co? Co means among or between two, and relation means you know it. How are things related, right? So if I add these two things, then I get correlation. So what is correlation? It is nothing but a measure that shows how are two random variables correlated. Okay, so what does this thing actually mean if if I want to show it to you? Actually, for a correlated value, okay, suppose you remember that example that I just gave you in the previous video. Yeah, let's talk about that. Let's say that you had expected a value of say 99, if I'm not wrong. Okay, I do remember things right now. So you have expected a value of say 99. All right, all right. So if you have expected a value of 99 and you have got some value, say your result has come out and you are not so lucky, and from 99 you have got something less. Right? You've got something less, or it may happen that you have got something more. Okay, and what did the uh, authority do? They had to see that how did the entire paper of the students go, how did the entire exam go for a particular subject. So what did they do? They took up the data set of all your statistics marks. Okay, all your stats 2 marks, they have this data set. Okay, and then they saw how much dispersion is taking place from a mean or median value that they have chosen. Okay, how much dispersion is taking place? They plotted the entire value. Okay, they plotted the entire value, these data sets value, in a graph. Okay, they plotted it, and when they actually drew a line, the line of best fit, it came out something like this. Okay, so in this case, what could they conclude? That there are no strictly um aligned values to this line. Okay, And since there are no strictly aligned values to these lines that they have drawn, so your marks are not correlated with each other. And why did they check this? Suppose if they wanted to check that how many people have cheated, they might be wanting to check it. But I mean, I doubt that in a CBT that really happens. Okay, so they have wanted to check this, and they have plotted all your marks, and they have checked this thing. Okay, so what is actually correlation according to them? They have seen that the marks of any student A and the marks of any student B, they are highly dispersed from the central line. So if they are highly dispersed from the central line, and it's for all of the cases that I have mentioned. Okay. So if they are highly dispersed from the central line, then it means that the values are uncorrelated. Now, what is this correlated, uncorrelated? What does correlation actually mean? What does uncorrelated? What does correlated? What are these things? You see, I have written a definition. It says a measure that shows how are two random variables correlated. But what are the things that are related to correlation? What is correlation? Um, uh, the correlation thing, which is often denoted by rho xy. Rho xy is nothing but a measure of of not of it is a measure of the dependence of two random variables x and y. Okay, so the correlation thing, what do we call this? First of all, we call this the correlation coefficient. Okay, so what does this correlation thing actually do? What does this correlation coefficient actually do? It measures the dependence of the two random variables x and y. Okay, so since it measures the dependence of the two random variables x and y, then we know that for this case, either two variables, they can be correlated, okay, or uncorrelated. Okay, so if they are correlated, how much can they be? What is the extent of their correlation? So we have something that says that the value of rho xy will be strictly between -1 to 1 and without these intervals included. Okay, this is the definition of the correlation coefficient. So if they are correlated, at max they can get the value of rho xy being lesser than 1 or not lesser than 1. If they are correlated in a positive manner, okay, if they are correlated in a positive manner, that means x changes as y is changing. Okay, suppose if x increases, then the value of y will also increase. Then they have got a positive correlation. If x decreases, then y also decreases. They have got a positive correlation because they are directly proportional to each other. Okay, so in this case, correlation will be 1 and this will be positive correlation. Okay, this will be positive correlation, right? Now if rho xy tends to -1, okay, and if it tends to 1, then they should be strongly correlated. That means highly correlated to each other. They should be highly relatable to each other. Okay, and in the same manner, Now if rho xy, it tends to -1, then what happens? X and y are inversely proportional for this case. So if x increases, then y decreases and vice versa. And if x decreases, then y increases and vice versa. So this is for the negative case when the correlation coefficient is negative, right? So this is all about the value of correlation if two variables are related. And if they are not related, then obviously rho xy will be 0. But how did this come from? What is the formula? We are talking about correlation coefficient. We are talking about correlation. We have known what is correlation. We have seen that it's a measure. But how should we measure it? So there is another formula that says rho xy equals covariance of x comma y divided by sigma x into sigma y. Now, what is covariance of x comma y? We have just studied in the previous part. This one. This entire thing is called the covariance. This is called the covariance. And what is this? This is the standard deviation of x. And what is this? This is the standard deviation of y. About correlation coefficient and how to measure it. And do you want to see the graph that how will they be plotted? If the correlation coefficient is negative, then the graph will be something. If the or if they are highly negative, okay, if they are not correlated or not, I won't say not correlated. If they are correlated in an opposite sense, okay, then the values. What will be the values? If this is the sorry, yeah, if this is the x-axis, this is the y-axis, then for x being in an increasing manner, y will decrease. Right? Yeah. So the thing will be like this, right? You can say a parabola, but it's not a parabola. Things like these will be taking place, right? And if I draw the line of best fit, okay, if I draw the line of best fit, then something like this will be coming. Okay, so they are clustered around the line of this best fit, but in an opposite manner. What is this called? Line of best fit. Okay, and for this case, are closely clustered in an opposite manner. And what will be the line of best fit for this case? Something like y equals minus x. And I hope that you know it, right? Because we have studied in Maths 1 how to draw the graphs of lines. And specifically, we have studied in class 10 as well. So it is easy. Okay. And if rho xy equal to 1, the graph, it will be nothing. Since x increases when y increases, then the value of x is depending in a positive manner as compared to the value of y, right? Or I should say on the value of y, then it will be a line which is y equal to x. So this will be my line, okay, line of best fit. So if I draw the line of best fit, or if I actually plot the points, I'll be getting a graph, a scatter plot like this. Okay, and if I plot the line of best fit, I'll be getting a line like this. Okay, the points might lie on the line, that's not a very big deal, but I'll be getting a positive slope line, which will signify that rho xy is equal to, not equal to, it's tending to 1, and rho xy for this case, it's tending to -1. And what if it's uncorrelated? No problem. Then that means there will be no line. or even if there is no, even if there is any line, it will not be actually providing me any information regarding this. Why? Because the points here are closely clustered in um, a positive manner. Okay, and for this case, the points are closely clustered in a negative manner. Okay, and if I draw the scatter plot for two variables being uncorrelated, as I showed it to you in the previous example of your exam thing, of your exam example, the plot will be something like this. Okay, and no matter where from I draw the line, do you see the close clustering of any points? No, they are dispersed. They are highly dispersed. So since they are highly dispersed, can they be closely related? No. So no clustering. Okay. So since it is not clustered, so the relation correlation coefficient, you can zero. Okay, or something tending to zero. It can be anything because it takes the value zero. So the rule of the thumb is number one: points are in negative or in decreasing manner in y equals x plot, then that means it has a negative correlation. Not zero. Yeah, it's zero. Second, points are in increasing manner for y. I mean, you have to take an inference from graphs like these. Okay, so in this case, for y equal to x plot, rho xy, can you see rho? No, I don't think so. Just a minute. Let me remove it and let me write it again. Yeah, rho xy is greater than 0. And then third, points don't cluster or are, or I should say point don't cluster towards any direction. Why should I say this? Because points are clustering towards a direction in this case. But if they don't cluster, then what's the point, right? Points don't cluster in any direction. Just a minute, what did I write here? Yeah. Points don't cluster in any direction, then I can say that rho xy that is equal to 0. Okay, that means you cannot infer anything from that scatter plot. So this is something that you should know. This is the main thing that you should know. First the formula, then the value, okay, and then this. If you are able to know this thing, and this thing, you have understood correlation perfectly, and I don't think that there will be any question that will be missed by you. So let's see if any question gets missed by you. So the first question, write in your screen, and a very formula based one, as I can see. The covariance of two random variables x and y is 1.5, and the variance of, what the hell? Yeah, the covariance of two random variables x and y is 1.5, and the variances of, what's happening here? Yeah, and the variances of x and y are 1 and 4. Find xy, or you can say rho xy. For this case, how do we proceed? You see, the covariance of x and y is given to us as 1.5, and variance of x is given to us as 1, and um, variance of y is given to us as 4. So for that case, so for that case, sigma x, okay, sigma x is plus 1, right? Why? Because sigma x is the positive square root for this case, and sigma y, that is plus 2. Okay, sigma y is the positive square root for the variance of y. Therefore, if I have to find rho xy, how should I find it? We know the formula, right? We know it. We are studious people, we know it. I mean, I do know it, but I doubt that if you do. No, no, you know it. Okay, rho xy. Don't take it to be fxy. Okay, so what is the value for this case? The value for this case is 1.5 divided by 1 into 2. So that's 1.5 divided by 2. And if I calculate it with the help of my computer, I'm very bad at math, but I do think that it is 0.75. If I'm not wrong, just let me calculate it. Yes. Okay. Yes. Yes. Yeah and yes. Okay. So it's 0.75. Therefore, rho xy is equal to 0.75. So what does this mean? In this case, if I draw the plot, if I draw the scatter, it will be scattered, but a considerable amount, maybe 75% of the points that I am drawing in the scatter plot, they will be following an up. See, can you see it? Right? They'll be following an uprise in the opposite direction. So by this method, I can say that rho xy is also equal to 0.75, or I cannot say the value, but it's definitely greater than 0. Just yeah, greater than 0 and tending to 1. Okay. All right. Now, inequalities. What are inequalities? First of all, you want it right now. This will be just a topic for you guys at this point of time. You'll be able to understand the meaning, the true meaning of inequalities in your week 8 and uh, so on till week 8. I should say. Okay, in your week 8 and so on from week 8. So you won't be able to understand that why are we studying it right now. I mean, you will be able to understand it. I will make sure that you will, but you won't be able to predict that why are we studying inequalities right now. I mean, everything was being equal, it was good, but why inequalities? But you will be able to understand it very soon if you keep track with your studies. Okay, all right. So what are inequalities? First of all, a very important thing. These two inequalities are in our syllabus. There is one more inequality, Chernov's inequality, which is not in our syllabus, thankfully, and that has a very nasty formula and a very nasty format. But this thing, Markov's inequality and Chebyshev's inequality, these two inequalities will be given to you. These will be given to you in question 2. All the pictures that I've taken from all the pictures I've taken for this PPT, they are from your question paper. Okay, so this is something that you should remember, that these will be given to you for your um, questions, but they will necessarily not be providing you with the meaning of it. So let's deep dive into what does it actually mean. We have seen that for any value, okay, for any value which is not a central value, we can write some probability x being greater than or equal to c if it's discrete as probability x equal to, if I write, what did I write just now? What the hell? Yeah, if I write summation I equal to 1 to, say, the c is at the mth position, so 1 to n minus mth position, so all the numbers, all the i's before these values, or before the value of c, x equal to xi. This is something that we have done for the case. Okay, the probability being uh, greater than or equal to, or I should say, if I reverse it for this case, reverse it. Just a minute. Yeah, probability of x less than or equal. So if I replace c with 4, then, and if x takes the values 0, 1, 2, 3, 4, 5, 6, 7, and 8, then what will be the probability that x is less than or equal to 4? How will I do it? Probability that x equal to 0, or probability that x equal to 1, or probability that x equal to 2, or probability that x equal to 3, or probability that x equal to 4. So this is the basic knowledge and definition of an inequality. But there is one very bad thing for this case. If you are not given the probability mass function, okay, or for the continuous case, if you are not given the probability density function, okay, if you are not given the probability mass function, neither you are given the probability density function, and you have been told the mean of the distribution and the variance of the distribution, okay, and you have to find the probability of some cases. We'll be seeing that in the subsequent questions. How will you do it? So if only mean is mentioned, then for this case, it will be probability that x is greater than or equal to c is lesser than or equal to mu upon c. Okay, where what is the value of, what is the meaning of mu? It is nothing but the mean or expectation, you can say. All right, and for the variance, if variance is also given to you, then and if you have to find the probability within a given interval, say 100, 180 to how much should I add? Say 20, or sorry, I've just reversed the entire mathematics right now. I say I'm not good at math. Okay, if some interval is given to you, then you will be using this inequality. And why should you use this inequality if any interval is given like this? The main reason is modulus of x minus a being greater than k, that opens as x being greater than k. Just a minute. Where's my eraser? Yeah, here it is. X being less than k plus a, and x being greater than k minus of a. So this is the main reason because of which you get an interval. And if you see, for this case, if I write in this entire interval as in this form, then I'll be getting something like probability that x minus 80 is greater than 100. Why? Because um, not k minus a, yeah, k minus a. So if I write it, then 100 plus 80, that's 180, and x, and 100 minus 80, that is 20. And this is the exact thing that we have got. Okay. So for inequalities, I will be writing this. I'll be writing this. Don't worry. For inequalities involving, um, just a minute. Yeah. Use this when x takes values in an interval of say a to b. Okay, or I should include the closed brackets in here. Yeah. So if x takes any value that is in the interval of a to b, we should use this. Okay, and this can be manipulated as well, because this can be also written as 1 minus probability that x minus mu lesser than or equal to k sigma, that is less than or equal to 1 minus, 1 by k squared. We'll be seeing this. We'll be seeing how to manipulate it, and you'll be getting a natural instinct. You can just say that probability of A plus probability of A plus probability of A complement, that is equal to 1. So any opposite to this event, and the opposite of greater than, that is less than, so it will be 1 minus the opposite of the, 1 minus the event that is given to us. And when to use this thing? When only mean is given and no intervals for capital X. That's it. You understand these two concepts, you understand when to use it, and then you are good to go. Okay, so since you are good to go, I believe, if you are not, rewind the video, look into this part, and then proceed. Okay, so if you are good to go, so let's do some questions. The question says that a shopkeeper sells mobile phones. The expected demand for the mobile phones, see, expected demand for the mobile phones is 4 per week. So E of x, that is equal to mu, when x is the, what is x? Yeah, x is the number of phones sold. What the hell? X is nothing but the number of phones that are sold. So E of x, that is mu, that is given to us as 4. Okay, all right. And based on the given information, choose the correct option for the random variable x denoting the number of phones. You see that x here, does it take values in any interval? I don't think so, because it's not given to me in the question. Does x have mu? Yes, it has. So if x does not take any value in the interval, if x has mu, what did I teach you? Use the Markov's inequality. So according to Markov's inequality, E of x, or not E of x, what was the Markov's inequality? Yeah, probability that x is greater than or equal to c, that is, I guess, lesser than or equal to, yeah, lesser than or equal to mu upon c. So what is c? What is c here? You see in the option 10 here, in option C there is also 10. Option B, you have got the inequality portion, the right hand side of the inequality portion, it has got 10. So can I infer that since it matches specifically this format, it matches with my format of Markov's inequality, can I just take a trial to substitute the value of C as 10? And if I do it, then probability that x is greater than or equal to 10, that will be lesser than or equal to mu upon 10. So what was mu? Probability x is the value of mu was 4 by 10. So the probability of x greater than or equal to 10 was less than or equal to 0.4. So this is the first thing. And now it's also told to us that we have to calculate the reverse, because the opposite. So the opposite of greater than or equal to, it's always less than. So if we calculate that, 1 minus probability of x being greater than or equal to 10, that is equal to probability of x being less than 10, that is, or probability that x is less than 10 is nothing but 1 minus 0.4. So probability that x is less than 10 is 0.6. Okay, first answer, sorry, second answer, and this is the first answer. So let's just put the values and check for it. Option A, probability that x being greater than 10 is greater than or equal to 0.4. Greater than or equal to, no, a big no. Probability that x is greater than 10 is less than or equal to 0.4. Yeah, this is the answer. Probability that x being less than 10 is greater than or equal to 0.6. Greater than or equal to 0.6. No. Oh, from that thing, yeah, I did make a mistake here, and let me just clarify it. Yeah, so it's less than or equal to, so it's not less than or equal to, it's greater than or equal to. But here I've got this gentleman waiting, which exactly matches with the second option, so this is also the correct one. So the correct options are B and D. Okay, all right. The second question. Suppose a fair coin is flipped 200 times. Find an upper bound on the probability that the number of times this coin lands on heads is at least 130 and at most 170. Okay. You see, let us define x first. Number of times the coin lands. Number of times the coin lands. This is the, sorry, coin. What did I write here? Suffering from delusion these days. Yeah. So number of times the coin lands, it's x. This is the random variable that denotes x. Okay. All right. And you see, it's at least 130 and at most 70. What did I tell you? X is at least, sorry, yeah, x is at most 70 and at least 130. Okay, so this is the probability, and I have to find an upper bound on this thing. Okay, so does x take values in intervals? Yes, it does. So if x takes values in intervals, then shouldn't I use my Chebyshev's inequality? The answer is yes, I should. So if I should use my Chebyshev's inequality, I have to find mu. Now again, the number of times the coin lands on heads. We just saw it in the previous video, guys, that this is nothing but a binomial distribution because it represents the number of times the success takes place, and it's nothing but n times p for binomial distribution, as we know from stats 1. And if we just put it, and it's fair, so it's 100, and sigma squared is nothing but npq, that is np into 1 minus p, so that is 200, just a minute, what the hell, yeah, 200 into, what is p, half, and what is p here, it's half again, so just cancel it off, and it's 50, so the value is 50. Okay, therefore, now how should I find the value of k? You see, it's written to me this thing, 130, right? It does not seem correct, right? What if I can write it in the correct form? The form will change, that's for sure, but what if I write it in this format? something correctness, something correct is showing right now. Now, if I subtract 30 from the left hand side and add 30 to the right hand side, what will I get? X minus 30. I guess I mean only for this case. Okay. Yeah. So x minus 30, and this is nothing but just a minute. Should I? Yeah. Oh, no, it's not thank you till now. So 100, and if I add it in, um, if I subtract 30 from this place, so am I getting something known, since this is nothing but um, mod x minus a being greater than or equal, or sorry, mod x minus a being lesser than or equal to, yeah, being lesser than or equal to k is similar to x lesser than or equal to k plus a and k minus a. So I have to find the value of k right here, right? That is the thing. Yeah. So to find the value of a here. So if I substitute k as 100 and if I substitute a as 30, do I get 70 in here? Yes, I do. If I substitute k as 100 here and a as 30 here, if I substitute, and do I get the value as 130? Yes, I do. So for this case, I can say that it's as good that this thing x minus, yeah, it's as good as writing x minus 30 lesser than or equal to, what was it, 100 for k, right? So if this thing has been done already, therefore probability that mod x minus a less than or equal to k sigma is equal to, sorry, is less than or equal to, again, uh, or it's, sorry, it's greater than or equal to, greater than or equal to k sigma, it's 1 by k squared, it's less than or equal to 1 by k squared. Okay, so what did we find? X minus a being less than or equal to k. So can we just do it in this fashion? X minus a less than or equal to k sigma. Yes, we actually can, right? And if you notice, this is something that um, you know we have to find out. Okay, this is something that we actually have to find out for ourselves. And if we do that thing, if uh, if we do that thing, probability x mod x minus 100 being greater than or equal to um, k times sigma, what was k? Um, was it 100? Um, no. Yeah. So k sigma was nothing but 30. Right? Why? Because I have subtracted nothing but 30 in here. Right? Okay. So probability of mod x minus 100 greater than or equal to 30 is less than or equal to 1 by k squared. And what is the value of k directly? The value of k was, say, 100 into the value of sigma, or sorry, the value of k was not decided. Just got confused with the variables. And what was the value of sigma? The value of k times sigma is equal to 30. Okay, so the value of k times sigma is since it's 30, so k will be 30 by sigma, and sigma is nothing for this case, but it's root 50, right? Yeah, so 30 by root 50. Okay, so what will this thing actually stand out to be? 500 divided by, not 500, 50. Yeah, it's 50 divided by uh, 900, a tiresome calculation, to be very honest. Therefore, probability that mod x minus 100 is greater than or equal to 30 is, the upper bound is 5 by 90. Therefore, the value for this upper bound is 5 by 90, and that is the answer. Okay, I hope you have understood this. And how did we approach this? First, we put it in a normal fashion and get the values of a and k. I should not have used k here. Let's, so that when you get the notes, you will be comfortable with this case. Okay, and then since k1 is nothing but k sigma, this value is nothing. Sorry, not this one. Yeah, this one. Since this one is nothing but k sigma, we found out the value of k by substituting it. Okay, by substituting it, and then once we found out the value of k, we just use the Chebyshev's inequality. So since we used the value of the Chebyshev's inequality, we have got a value of 5 by 90. Okay, and that is the upper bound for the experiment. Okay, for the event that was given to us. So with that, we come to the end of our week 3. We had a lot of things to study, right? But trust me, these are important for you. Specifically, week 3 and week 4, these are the hot spots from where questions are asked. And to be very honest, questions are not that tough from week 3 and week 4. Okay, we will be doing some PYQs if time permits, and you'll be seeing that they are not tough. Or you can just go to the website. I'm writing it in quiz practice dot space. You can just go to this website and you can just see for yourself that the PYQs, what are the PYQs that have been asked. And believe me, PYQs are not tough if you understand things and not just blindly memorize them, as I told you in the guidance session. So with that, we come to the end of the video. Thank you everyone for watching it. Thank you again. Please do like, share, and subscribe. And we meet in the next lecture. Thank you.